All right, our lesson on graphing systems of linear inequalities should be pretty quick. I've only got 3 examples in this lesson. I just want to remind you real quick before we start. When we talk about graphing systems of inequalities, we've talked about this before. You've got 3 different options. So remember, we could have one solution. When we do lines, right, we could just have one solution where they cross, or we had no solution when they were parallel, or we had infinite solutions when we had 2 lines that were right on top of each other. So today we're not going to be talking about just lines, we're going to be talking about inequalities. Remember, inequalities, that's when we're going to be asking ourselves things like solid or dashed and above or below. So everything we do today is going to have shading involved. So we just need to remember those rules. So what I want to show you today, our solutions are going to look like 2 inequalities that are right on top of each other. So let's say maybe one of them is supposed to be dashed and shaded below. So dashed and shaded below. And then maybe we have another one that's a solid line. Ooh, let's do a line first. A solid line. And then let's say this one is shaded above. Now they may be shaded the same direction. They may both be solid or both be dashed. That's fine. When we talk about systems though, notice here it's not even that they're just sharing one point. So like there is a spot where they're overlapping, right? We've got this spot right here where the 2 are intersecting one another. But you should notice that there's also an entire like shaded area that they both have in common. So now the solution, we can't name it, we can really just kind of point to it because it's a whole set of points. So when we talk about our solution set, this area where they're both shaded, that's going to be our solution set. So when we graph that, you can either make it darker or most of the time I think people just like to point and say this is our solution set, which means we can pick any point that's in the double shaded area to be a solution. The other thing that you need to note is that points that are on this solid line are also solutions. So if they're on a solid line, they are solutions. But if they're on a dashed line, they are not solutions. So if it's dashed, any point you pick there is not a solution because think that's like an open circle, so the point isn't actually there. All right, so here in our first example, I'm going to recopy my equation, 3x plus y less than or equal to 1. You should always ask yourself in standard form if it's easiest to do cover-up method or if we need to solve this for y. If I do cover-up, my first equation is 3x is less than or equal to, or I can even just write it as an equation equal to 1. The problem is that's going to give me a fraction, and I don't like that because I'm going to have to divide by 3. I don't want to do a fraction. So instead of doing that, I'm going to solve this equation for y. So I'm going to subtract 3x so that I can move it to the other side. So now my equation is going to say y is less than or equal to negative 3x plus 1. The things I want to note before I start graphing, this is going to be solid, and because it is less than, it is going to be below. So I'm going to start at positive 1. This is a slope of negative 3 over 1, so down 3 over 1. Do make sure you go as far with the pattern as you can on these. And then I'm going to go ahead and get my shading done. Solid, and I want to shade below, which is on this side. Okay, I'm going to switch colors now. I'm going to do my second equation. And that equation, I'll just make the note up here, that is going to be dashed and above because it's greater. So start at negative 2. We're going to do dashed, or I'm sorry, rise 2, run 3, down to backwards 3. That's as many points as I can fit. I want this one to be dashed. And we want to shade above here. So tomorrow in class, we'll use colored pencils to kind of see this area a little bit more easily. But you should see that your solution area is this kind of section in this corner where everything is overlapping.
One thing that you do need to be able to do is name 2 points that are solutions and 2 that are not. So, we want to name 2 solutions, and 2 solutions would just be 2 points that are in that area. So an example might be, let's see, 0, 0. All right here in the middle, 0, 0, that is a solution because it's in my gray shaded area. Also, I'll pick a point. Let's see, this point right here, because it's on the solid line, it is a solution. So -1, 4 is a solution. And then they're going to want us to name 2 things that are not solutions, just so you get in the habit of seeing things that don't work. So something that is not a solution would be, let's see, 1, 1 right here. It's in one of the shaded areas, but not both, so it is not a solution. So 1, 1. Also, any of my points that are on my dashed line don't work either. So this point back here, that's at -3, -4, it is not a solution either because it's on the dashed line, which is not included. All right, make sure you picked up on all the parts of that example. Okay, so the second and last example are when we talk about parallel lines. Now, you're used to parallel lines always having no solution. But when we talk about shading and inequalities, it may or may not have no solution. So we just have to see what it looks like. All right, in example A here, one of my lines has been shaded below, the other one has been shaded above, and because those 2 sections are not overlapping anywhere, there is no solution because there's no place that you're shading both lines. So this would be an example of no solution. You may want to do just a real quick rough sketch of that in your graph. Now the second one, B, let's see, I'll graph that for us real quick. We want to start at -2. We're going to do dashed and above. All right, so this is just a rough sketch. All right, so there's my first line. And then my second line is going to be at +4. It's going to be solid. And this time we're going to go below. So that's a little hard to see with the colors that I chose, but let me shade in for you. On this one, there is a shared area, and that's this kind of like section in the middle. All right, so this section in the middle is where the solution is, because even though these lines are parallel, the shading areas do overlap. So this does have a solution, and it's the section between the parallel lines. So make sure that you understand parallel does not always mean no solution if you have inequalities and shading. And that's all I've got for you. We'll work on this tomorrow.